All right, today what we're going to do is talk about the classification of matter and how we can take anything and put it into a certain category. And so first thing we're going to do is we're going to talk about everything. Everything is pretty much all things. It's matter, it's energy, and it's just anything that's within the universe. Now, one thing that matter can be broken up to is it can be broken up into energy. And energy is the capacity to do work. You can see energy in the form of light and heat, but you can't touch or feel it. However, that's something that energy is something that we're going to talk about later on in the year. But what we're going to focus on today is matter. And so matter is anything that has mass and volume. So it has mass and volume. In other words, it takes up space. It has mass and takes up space. You can feel it, you can taste it, you can touch it, smell it, whatever. Now, all matter can be broken up into two categories. And the first category is going to be a pure substance. And so we're going to go and talk about a pure substance. Pure substance is one kind of matter. It's one type of matter. And when you have a pure substance, the only way you can separate the components in there is by chemically separating it. For example, water is a pure substance. If you had pure water, you only have one type of thing, which is H2O, which tells us we have two hydrogens and one oxygen. And the only way to separate the hydrogens and the oxygens is to chemically separate them. You cannot physically separate the hydrogen and the oxygen. Now, pure substances have two categories that those can fall into. The first one is going to be an element, and an element is found on the periodic table. And an element, so anything on the periodic table is an element. And so, for example, gold is on the periodic table. It's an element. Oxygen's an element. Carbon's an element. So if you were to have pure carbon, that would be classified as an element. And it's made of one type of atom. So it's made of one type of atom. Now, what I will say though is if you take a look at the example below, you'll see that this right here, each one of those molecules has two atoms. But it doesn't matter that there's two atoms. What matters is how many types of atoms are there. There's only one type of atom. Now, the next thing that a pure substance can be classified as is a compound. And a compound is two or more elements. And again, it's two different elements held together by chemical bonds. And so it has a fixed composition and it cannot be separated by physical means. You can only chemically separate it. And I'm going to go ahead and write an example down here. I'm going to write in a different color. H2O is an example of a pure substance that's a compound. You can see that we have two types of elements there. We have hydrogen and oxygen. You can see here is another example of a compound. There's two types of atoms, and then even within here, you have two types of atoms together as well. So that's the two options for pure substances. There's one type of substance, it can either be an element or a compound. The next type is going to be a mixture. And so a mixture is formed when two or more substances are physically combined. They're physically combined. To give you an example, you can physically combine a salad. You get the olives, you get the lettuce, you get the cheese, and you physically put them together. However, all substances in a mixture will retain their properties. And to give you an example of that, when we mix the salad together, we put the olives and we put the lettuce and we put the cheese. The olives are delicious before you put them in the salad, and they're delicious after you put them in the salad. And so no matter what you do, you can mix them all around. Olives are still delicious. It's a property of olives. Now you can, it can be separated physically or picked apart. For example, if you're someone that really likes olives, you can scoop some salad for yourself and then pick out some extra olives to put inside of your salad. And you can pick them out and you can eat them one at a time. And so you can physically separate a mixture. Now there's two types of mixtures. The first type is a heterogeneous mixture, and the second type is a homogeneous mixture. Now, the prefix hetero means different, and the prefix homo means the same. And so the two types of mixtures that we have is we have a mixture that is different throughout. That's a heterogeneous mixture. It's different throughout. An example would be like a salad. A salad, you can see the differences. A homogeneous mixture, however, is the same throughout. So the mixture, you cannot see a difference throughout. And so let's go ahead and take a look at some examples here. So the prefix hetero means different. And each sample taken will be different. It will be different. And if you think about the salad is an example of a heterogeneous mixture, because when you take a bite of a salad, it may or may not have delicious olives in them. Also, when you get to the bottom of the salad, that's where you get like the accumulation of all of the dressing and the cheese, which is delicious as well. And so each bite you take is different. A pizza is another example of that. Each bite of a pizza you take is going to be different. And so that's an example of a heterogeneous mixture. Now, another example would be like rocks. If you were to go out to Enchanted Rock and get a piece of rock, each rock you get might be a little different because it's a heterogeneous mixture. And specifically, heterogeneous mixtures, you can see differences. You can see the differences throughout the heterogeneous mixture. So they look different throughout the mixture. You can see differences. They are unevenly mixed. Now the prefix homo means same. And so a homogeneous mixture is the same throughout. And a perfect example of this is a Gatorade. A Gatorade is a homogeneous mixture. The first sip of Gatorade is exactly like the last sip of Gatorade. If you were to take a sample out of the top or the sample out of the bottom, both samples would be exactly the same because it has a uniform composition. So each sample taken will be the same. It even looks the same throughout the whole thing. It looks the same throughout. You cannot see any differences. Now, alloys are a mixture of two metals. And alloys are a great example of a homogeneous mixture. Any sort of brass instrument is going to have an alloy. And if you look at like a brass instrument, or even this ring here, this is my wedding ring, you can see it looks the same throughout. But this is a mixture of gold and I believe nickel. So I'm not for sure on that though. But anyways, the alloys are metals that have a mixture. Another great example of an alloy is steel. Steel is a mixture of iron and carbon, but you can make steel, like a steel sword, where it's the same throughout. And so they are evenly mixed. Now let's go ahead and take a look at some examples here. When we look at these examples, we want to think about the flow chart. So we have all matter, and matter can be either a pure substance or a mixture. And so the thing you need to ask yourself is, can you separate it physically? Well, a salad, you can physically separate a salad. However, water, you can't physically separate the hydrogen and the oxygen. So if you cannot separate it physically, then what that means is it's a pure substance. If it has more than one type of atom, it's going to be a compound. If it has only one type of atom, it's going to be, or one type of element, it's going to be an element. Now a mixture is again something you can physically separate, and then you have to ask yourself, is it uniform throughout? If you can see differences throughout, for example, you can see differences throughout a pizza, then it's going to be a heterogeneous mixture. But let's think about this pin here. This pin, this outer coating of the pin, just this black part right here, this is a mixture, and if we consider only just this part right here, does it look the same throughout? And the answer is yes, it does look the same throughout. It is a homogeneous mixture. And so let's go ahead and take a look at some examples here. So examples of elements might be gold, iron, oxygen gas, and some examples of compounds might be water or carbon dioxide. Some examples of heterogeneous mixtures might be pizza, granite. If you happen to have granite countertops, go look at them. You can see the differences. You can see like the little, specks and things within there. And then some examples of a homogeneous mixture. Salt water is a good example. Now, what about coffee? Coffee might be a good example, unless it's coffee from the gas station, which has those little floaties in there where the grounds get in there, which wouldn't be homogeneous. But Gatorade, those are all examples. Now let's go ahead and take a look at the example. We're going to just say E, C, He, or HO. So E for element, C for compound, He for heterogeneous, and HO for homogeneous. So a pizza is definitely not a pure substance. It's a mixture. It looks different throughout. This is going to be a heterogeneous mixture. Gold. Notice how gold, here's the symbol for gold. It's one type of element. So we're just going to call it an element. Now sugar, if we have pure sugar, that's a pure substance. However, is sugar one type of atom or more than one type of atom? Well, there's actually three types of atoms. There's carbon, hydrogen, and oxygen. And so that's actually a compound. Water, H2O, is also going to be a compound. Then we have sodium bicarbonate, which is this right here. Again, that's going to be a pure substance, but it's got more than one type of element in there, and so it's going to be a compound. Iron is going to be an element. Iced tea. Now this one's kind of a hard one, and I think this one is debatable because think about like iced tea. If you buy iced tea from like Walgreens and you get it out of the cooler section, the iced tea you get might look the same throughout. And so that actually could be homogeneous. However, what if you make some tea on your own and some of the tea leaves get in there and you see the little floaties in there, you can actually see the differences throughout. And so this one is up for debate. I'm going to go ahead and say that if it's iced tea that you make, maybe you have those little floaties around there, and we'll say that it's heterogeneous. But if it's iced tea from the store, we'll say it's homogeneous. So it all depends on if you can see the little floaties. Now, what about pool water? Well, let me ask you, have you ever swam down into the bottom of the pool with your goggles on and you get down there and you see the little floaties in there? Well, that also would be telling us that the pool water is heterogeneous. But what if we had the perfect pool that was perfectly clean? Would that be heterogeneous? Well, if it was perfectly clean where it didn't have little nasty floaties in there, then we would probably say it's homogeneous. So again, this one's up for debate. I'm going to go ahead and say we live in a perfect world, and so we're going to say it's perfectly clean, and if it's perfectly clean, we're going to say it's homogeneous. And then brass. Brass, again, is a mixture of copper and zinc. Notice how if it shows it to you like this, where it shows you the two metals, where it says one metal and another metal, that is going to be a type of alloy, which is actually a type of homogeneous mixture. And so those are all the examples of heterogeneous, homogeneous compounds and elements that we're going to go through right now. And we will have some more examples to show in class. If you have any questions, feel free to ask and attempt the practice problems that are below on the page below here. All right, have a great day.